Here is part 2 to your Chapter 6 study guide. For number 7, we have a 3-part problem here. Mrs. Thompson has a Sam's Club membership. She has a gift card worth $2,000, and each month she goes shopping for supplies. We are to write an algebraic expression to represent the function first. To do that, we would need to put this in slope-intercept form, y equals mx plus b. So we need to find the slope, or the rate of change, and the y-intercept. So let's look at the table. It seems to be, in the x values, increasing by 1 each time. And in the y values, it is decreasing by $500 each time she goes shopping. Our slope is the rate of change. It's going down 500 in the y values and going up by 1 each time. So our slope is negative 500 over 1, which is the same thing as negative 500. So we put that value in for m. Now, to find the b, or the y-intercept, that would be the value when x is 0, what y is. And we got lucky here, and they gave it to us on the table. The 0 term is the y-intercept. So our y-intercept is 2,000. So our equation is y equals negative 500x plus 2,000. For part B, we need to identify whether the function is increasing or decreasing. Well, every time Mrs. Thompson shops, her value of her gift card reduces. So this is decreasing, but we have to explain why. So I came up with a statement like this, and your answer could vary or be similar. The function is decreasing because the output, or y values, decrease by 500 each time Mrs. Thompson goes shopping. So as long as you point out the value that's decreasing, or the range is decreasing, or output, that should do. And the last part, for part C, identify whether the function is linear or nonlinear. To be linear, you would have to have a constant rate of change throughout the entire table. And I think we have that. So if you look at the table, each time we notice that the x values are changing by 1 and the y values are decreasing by 500. So the rate of change is consistent throughout the table. Therefore, this is a linear function. So I said the function is linear because there is a constant rate of change throughout the table. Question 8. An agriculturalist collected data on corn yield per acre of land in 5 selected farms. For each farm, he measured the land area, x acres, and the weight of corn grain collected per acre, y bushels. Draw a mapping diagram to represent the relation between area and corn. So we put the area in the first block, and we put the corn in the second block. So I put my x values first, and then none of my y values repeat, so I just list those in the second block. Now, to map it, I just draw lines connecting the partners. 1 is partnered with 200. 1 acre has 200 bushels of corn. 2 acres has 400 bushels. The 3 goes with 600, the 4 goes with 800, and the 5 goes with 1,000. This is a 1-to-1 relation. So is this a function for part B? Tell whether the relation represented by the mapping diagram is a function and explain. Remember, to be a function, for every input, there is only one output. This is a 1-to-1 relation, so therefore this is a function. So our explanation could be something like this. Yes, this is a function because every input has exactly one output. If you wanted to give further details, you could talk about 1 goes with 200, 2 goes with 400, and etc. Question 9. This graph shows the distance of Joe's car, y miles, from town A over x hours. And the table here shows Mark's car, y miles, from town A over x hours. Step 1, or part A, says to plot a graph to represent the function in the table above onto the same graph as Joe's car. So we're going to take all these ordered pairs and put them on the graph. Let's do that first. So we're going to begin with 0, 0. That's the origin, a point right here. Then we go over 1, up 50. Over 2, up 100. Over 3, up 150. Over 4, up 200. Over 5, up 250. Then we're going to go ahead and connect those with a line. So that's what Mark's car looks like on a graph. Next, we have to write an algebraic expression to represent each function in the graph. Remember, when we write algebraic expressions, we like to write them in y equals mx plus b form. That means we have to figure out what is the slope and what is the y-intercept. So let's look at Joe's car first. Joe's car looks like it has no slope, or a 0 slope. There's no rise or run. It just stays at 50 the entire time. The y-intercept is 50. So we have no slope, but we do have the y-intercept. So Joe's equation, since we have no slope, is just 50. Now let's look at Mike's car. Now Mike's car has both. I can see a positive slope and a y-intercept. So let's do slope first. Let's make a right triangle on the graph. Remember, we do rise over run. So this rise is 50 and runs 1. So our slope is 50 over 1, or just 50x. Now we have to find the y-intercept. Well, this graph begins in the origin, so the y-intercept is 0. So we don't have to include that in our equation, but it's not wrong if you have it. So you could have y equals 50x plus 0, or you could just have y equals 50x. So what does this tell us about the cars? It tells us that Joe's car stays 50 miles away from town A as time goes by, while Mark's car moves further away from town A as time goes by.